Hello everyone, welcome to MK Maths. I am Karthik Mansali. In previous video we have solved the 1 5 marks question from the topic functions. So in that I have explained the concept of 1 and onto. So with that concept only now we are going to solve the second problem also. So let's start the second problem. So here second problem. So second problem says that state whether the function is 1 onto or bijective. It means they are asking us to find the given function f. So this is the f which has given f. F is a function from r to r defined by f of x equals to 1 plus x square. So this is the function they have given. So they are asking check whether the given function is 1 or not 1 check whether the given function is onto or not onto. If it is both, then verify it is a bijective or not bijective. Okay, so first we have to verify the given function is 1 or not. So let's start the solution. So solution, so here so here we have to find 1 so 1 okay, so 1 we have to find. So in a last video I have explained already. So the 1 concept, so to show it's 1 first we need a two elements from the domain. So here domain is r, so here domain is r. So let us consider x1 comma x2 belongs to r. x1 comma x2 belongs to r. This is domain. So in bracket I am going to write domain so that you won't get confused. Okay, so this r is nothing but first r. So I have considered the first r. First r here is a domain, second r is a codomain. Okay, so from the first r I have considered the two elements x1 and x2. So this x1 and x2 will have a images in second r, will have images in codomain. We call it as f of x1 and f of x2. So next for x1 we have an image f of x1, for x2 we have an image f of x2. Now suppose I assume that, so I use the word suppose. So suppose if these two images are equal, if f of x1 and f of x2 are equal in codomain, so what will happen in the domain? What will happen to x1 and x2 which are in domain? So that we have to see now. So now x1 and x2 belongs to domain r, I have considered. So suppose next I assume that f of x1 equals to f of x2. Now f of x means here the given function says f of x is nothing but a 1 plus x square. Okay, 1 plus x square. In the place of x now we have a x1, so I am going to write it as 1 plus x1 square. 1 plus x1 square equals to 1 plus x2 square. 1 plus x1 square equals to 1 plus x2 square. Now let us solve by cancelling which are equal here. So here plus 1 get cancelled, so the remaining will be x1 square equals to x2 square. The remaining will be x1 square equals to x2 square. Okay, so after squaring, if this is left side square, if that square comes to right side means it becomes a square root. Now next step will be x1 equals to plus or minus square root of x2 square, plus or minus square root of x2 square. So the next step will be x1 equals to plus or minus this square and this square and this square root will get cancelled. So the next step will be x1 equals to plus or minus x2. Plus or minus, why we are getting plus or minus means because we have left side we have a square. If that square, to remove that square we have to use a square root on both sides. If we use square root on both sides, then we will get a plus or minus, because plus value and minus value the square will be same. See for example, if plus 2 if you square the plus 2 you will get a 4 answer. So if you square the minus 2 also you will get a 4 answer. It means if we square a plus number or minus number you will get a same answer. So for that whenever we want to remove a square root or whenever we want to remove a square, we are going to use a plus or minus symbol here. Okay, so now we got x1 equals to plus or minus x2, but now we got a confusion now, because actually we need x1 equals to x2, but here we are getting x1 equals to plus or minus x2. We have to verify that. See here, x1 and x2 belongs to R. We have considered the x1 and x2 belongs to R. In this R means R is nothing but a real number. In real number we have a positive numbers, negative numbers, fraction, all rational, irrational, all those things are present in real number. So it means we have to write here negative sign. So here we have a negative sign, no plus sign, okay. Negative sign is there, no, we can't reject here. Negative, so negative sign cannot be rejected, cannot be rejected. Negative sign cannot be rejected, because why we cannot be rejected means because x1 comma x2 which are in R, here R is real number. In real number we have a positive, negative, fraction, rational, irrational, all those things we have now. So I have written the sentence here. Negative sign cannot be rejected. If negative sign cannot be rejected means one positive value and one negative value cannot be equal. So therefore we can write x1 not equals to x2, because x1 value will be positive and x2 value will be negative. It can't be possible. So one positive value and one negative value which is not equal. See here, for example, plus 2, we can't write plus 2 is equals to minus 2. It is not possible. So negative values here cannot be rejected. If negative values cannot be rejected means one positive, one negative, it's impossible. So x1 not equals to x2. So then we can conclude, easily we can conclude here, f is not 1 1. F is not 1 1 function. F is not 1 1 function. I hope you understood the concept here. 1 1 I have explained. So same, x1 comma x2 belongs to R domain. Suppose f of x1 equals to f of x2. F of x1 means I have considered 1 plus x1 square equals to 1 plus x2 square. From the question, 1 1 gets cancelled. X1 square equals to x2 square. If I move this square to right side, it becomes a square root with plus or minus symbol. X1 equals to plus or minus square root of x2 square. This square and square root will cancel. The remaining will be x1 equals to plus or minus x2. Here we have to check the negative sign can be rejected or cannot be rejected. Here negative sign cannot be rejected. How means? Because x1 and x2 are belongs to real number. Here real number contains both positive, negative, rational, irrational, all those things. So here negative sign cannot be rejected. So x1 not equals to x2. F is not 1. If we have x1 comma x2 belongs to n, if the question starts with the domain n means natural numbers means, then definitely we can write the sentence negative sign can be rejected. So here real number is there, so this negative sign cannot be rejected, so it is x1 not equals to x2. If it is from natural numbers means definitely we can write negative sign can be rejected, because x1 x2 belongs to natural number. Natural number does not contain a negative number. So then if it is a natural number, then we can write x1 equals to x2. F will be 1 1. So 1 1 not 1 1 all depends on the domain here. If in the place of domain R, if we change it to n, it becomes a 1 1. So in the in domain we having a now R value, so it is a not 1 1. If you consider integers also not 1 1, because in integers also negative value is there, negative sign cannot be rejected, then F is not 1 1. For natural numbers, for whole numbers only it is possible, because in those numbers only there will be only positive numbers. Okay, so I hope you understood this 1 1. Next move to the onto. Okay, let's move to onto now. Onto. Now we have to check for onto. So onto concept here we have to start with the codomain. Okay, so let us consider y belongs to R. Y have I considered. So in 1 1 I have used the letter X. In onto I am using the letter Y. Y denotes the elements which are in codomain. So this R is nothing but a codomain here. Codomain. This R is here. This R is a second set here. From this R we are getting a Y value. So from codomain we are focusing now, because now we are showing the given function is 1 or so given function is onto or not onto. So when it comes to onto, we have to focus on a codomain. So I have considered this y belongs to R. What I have considered y and what they have given f of x, both are same here. F of x is nothing but image of x which is present in a codomain, and I have considered the same point as a y now. So now both are equal. So y equals to the given question f of x as a 1 plus x square. So y equals to 1 plus x square. Now our aim is to find x value. Okay, y already I have considered. So from y we have to go. So in codomain, so this is codomain R. So this is domain R. So this codomain I have considered already y. So by using this y, we have to move to domain, and we have to find there is present x or not. If there will be a x which is present in domain, then it is a onto. If we can't find this x value in domain, then it is not onto. Our main intention is to find x value now. Now we have a y value. Now we have to find a x value here. To find a x value means we have to separate the x value and separate the y remaining values. So x square, as it is, I am going to write x square equals to this plus 1. If it moves to left side means it becomes minus 1. So y minus 1, x square equals to y minus 1. Now again x will be x equals to, if the square root transferred to right side means, I have already said if there is a square, then we have to use the plus or minus square root of y minus 1. Have to use square root of y minus 1. If we observe clearly here, x, we got square root of y minus 1. The, x is nothing but which should be present in domain. So our domain is nothing but a R here. Domain and codomain both are same here. So in domain R, actually in domain R means real numbers contain square roots. Square roots all present in a real number, but here we have to observe whenever the square root we got, square root inside there should be a 0. There should be a 0, or or square root contain only positive. So inside square root, wherever you see square root, first we have to check the square root inside there is a 0 or square root inside there is a positive number. Because if square root inside 0 means it is a real number, square root inside positive number means it is a real number. So whenever we get a square root inside negative number, then it is a complex numbers. In complex numbers we have already studied this minus 2, this minus 3, this minus 5, minus 4, all those things. Square root inside whatever negative signs we have seen, these are all nothing but a complex number. These are all nothing but a complex numbers. So in complex numbers we can study here in first PU. I hope you all studied in first PU. This is a first PU concept. So complex numbers. So here our main intention is only based on real numbers. We have not moved to complex numbers here. Functions we are going to study only on real numbers. Okay, so keep that in mind. So in square root there should be a 0 or positive. If you are getting a negative inside the square root, then it is not a real number. Then we can conclude it is not a real number because it becomes a complex number. So here y belongs to R is there. So if you consider any negative number, for example, if you consider any negative number, y equals to minus 2. Okay, y equals to minus 2. Just for example, okay, for example, I have considered y equals to minus 2. If you put in this x value, square root of y minus 1 is there. Now if we put this value, it becomes plus or minus square root of minus 2 minus 1 plus or minus square root of minus 3. So it becomes a negative number. Inside the square root they now become it negative value. So there are some y values which create a negative number inside the square root, which means this square root which is does not belongs to R. Which means this square root does not belongs to R. So now we can easily say that this R is nothing but a domain. Okay, this R is nothing but a domain, and this is does not belongs to R here. So this square root of y minus 1, actually square root will be real numbers. Wherever you say square root, that actually real numbers. But before to conclude a real number, before to conclude that a square root is a real number, first we have to verify what is the value inside the square root. If inside the inside value of a square root is a 0 or positive, then easily we can say it is a real number. So inside the square root, is there any Negative number means then definitely it is not a real number. So it means x belongs to plus or minus square root of y minus 1 we got. Our main intention is to check this x value which is present in domain or not. So to check domain which is present in domain or not means first we have to check what is the set of domain, what is the set contains. So set contains here a real number, domain contains real numbers. So real numbers means square root inside should be positive number, but here square root inside for some y value we are getting a square root inside negative, so which is does not belongs to R. In bracket you can write for some y. Okay, for some y means not for all y, for little bit some y it is not belongs to R. If is some y it is not belongs to R means definitely we can conclude that f is not onto. If it fail for one value also it is not onto. Okay, so it is not onto. It is not 1 not onto means hence directly we can say hence f is not bijective. F is not bijective function. F is not bijective function. I hope you understood the onto concepts here, onto concept also. So here nothing we have done. First we have considered this. Y belongs to R. This R is nothing but a codomain. From codomain we have considered the y and we made it equal to given f of x, and we solved for x. Y equals to 1 plus x square. X square will become y minus 1. X becomes the plus or minus square root of y minus 1. Now we have found the x value, but we have to verify this x value which is present in domain or not. If it is present in domain then it is onto. If it is not present in domain it is not onto. Simple. Okay, to verify which is present or not, first let us observe here x having the square root of y minus 1. We can conclude actually if we having a square root it is a real number, but when we have to verify also the value inside the square root. So if value inside the square root is a 0 then it is a real number. If value inside the square root is a positive number then it is a real number. When it comes to negative value inside the square root then those are all not real number. Those numbers will become a complex number. So we are not discussing complex numbers here, we are only finding the real numbers. So for some y value we are getting a negative value. So for example I have considered this y value as a minus 2, negative values. So if you put the minus 2 here in x value, it becomes minus 2 minus 1 means minus 3. So square root inside we are getting a negative number, so definitely it is not belongs to R for some y. So therefore directly we can write without any sentence f is not onto. If it belongs to R means then we have to write a sentence which I have explained in a previous question. In previous video I have explained for all y belongs to R there exists x is equals to f such that f of x, all those things I have explained that sentence. Only when it is onto, it is not onto, does not belongs to R, does not belongs to domain, then we can easily say if it is not onto, hence it is if it is not onto means definitely if it is not bijective function. I hope you understood this second question. So in remaining examples I am going to cover in next video, so watch those video also, then you are going to easily write a 5 marks question from this chapter, because from this chapter there are only 4 questions which may there are only 4 questions. In these 4 questions only you are going to get a 5 marks. So if you practice these 4 questions definitely you are going to get a 5 marks question from this chapter, from this concept, only about the concept function itself. Okay, I hope you all understood this video. If you not subscribed to my video, please subscribe and also like my video so that I get a motivation to do more videos. Okay, we all meet you in the next video. Bye.